Hey everyone, my name is Dave. Welcome to the NTD Racing Speed Shop. This here is Lefty. This is our budget race truck. Just got done racing the Mint 400 where we ripped our light bar off. And so we need to fix that. We're gonna build a bumper today, which is gonna require us to use just about all of the tools in the shop. Now, one of the neat ones we're gonna be using is that Swag Off-Road Hulk. And that is a tube roller. And one of the things that we're really trying to flesh out today is how do you roll a tube which generates a large radius tube and then translate that into something that you can use in Bend-Tech software and then generate tubes with computer aided design that we can cut on the Dragon A250. A whole bunch of new stuff for me today, and hopefully it will be helpful for you on your own projects. Anyway, we got a swag store. Please don't forget to subscribe. Let's go ahead and get to it. Let's take a quick look at how we're going to use this square tube. Again, this is a square tube that we use the Swag Off-Road Hulk to make the radius bend. And then in my previous video, I show you exactly how I use Fusion 360 and a couple dimensions off this to find the radius and all the information that we're going to be able to use in the Bend-Tech software. And so this is the light setup that we're going to go with. These are the Harbor Freight Road Shock lights. Again, I think the best lights at any price. I've had the most expensive and I've had the least expensive lights. These things are amazing, durable, waterproof lights, all the great things that you need in off-road lights. But what we're going to look at here is where we want the tubes to land on this square tube such that they don't interfere with the brackets that I'm going to make to hold these lights on there. I'm going to make the tubes basically land in the center over here and then in between these two end lights over here. So that's how it's going to triangulate in. And I'll be using 1.5 inch DOM tube for that, which will be cutting on the Dragon A250. So like I do in a lot of my videos, I do a lot of CAD here. That kind of gets a little bit boring. So I'm zooming through it right here. However, if you go to the end of this video, I put the full length CAD to show you exactly how I come up with all the information I do. And then I'm also putting at the very end the full length video that I made in the previous video, where I show you how I flesh out all the numbers from Fusion 360. Use this tube on Bend-Tech. Okay, let's take a look at the Dragon CAM software. And this is something I couldn't find on the internet before I owned it, so hopefully you will find this useful if you're interested in one of these in your own shop. But what I wanted to show you is kind of what you get when you launch the Bend-Tech software. Is you get Dragon CAM, and that's something that only comes with the Dragon machines, and then you get the Dragon CAD. And you kind of think of the Dragon CAD, as I click on it, as just this is the old school Bend-Tech software that you can, add a whole bunch of stuff to it. But what makes this a little bit different, and I'll kind of open up the Lefty file right here. What makes this a little different is as I go over to the tools now and I go to the tube library, and you can see I have a couple tubes over here which didn't transfer over because it's kind of a different account on my other computer. When I click on these, what you'll notice at the very top is you get a whole bunch of different options that we really didn't get before. And this is kind of the CAM part of this. This is where as we go into manufacturing, computer-aided manufacturing CAM. This gives you the kind of all the parameters which you're going to use on the hypertherm plasma cutter, some lead in, lead out, and those kinds of things. And you didn't get that on the normal Bend-Tech software just because it was just a CAD program. So to get those in there, what I did is this was the cut that Bend-Tech did, and these were the parameters that they put in. And what I did is I went down here and I said clone those, and I cloned it to make a 1.5 inch DOM and then also a 2 inch DOM, which we're going to be cutting today on the Dragon A250 for Lefty. So I'll close that out. And just, besides that, the software is pretty much the same. Here is Lefty's roll cage, which you can see on here. And there is the bumper that we're going to cut on the front. Now what we're going to do is we're going to take the CAD, the computer aided design, which is this Bend-Tech program, and we are going to now open up the CAM part of this. And so here is the part where, I'm learning this. So there's going to be some people who watch this who are much better at this than I am. And they're gonna be like, dude, you could have opened this a whole lot easier. And I am told, please put that in the comments for me and then also everybody else who's watching this. But this is kind of, at least how I was tinkering around, this is how I figured, because this is I'm only trying to get 6 tubes into CAM, computer aided manufacturing, and I got like 120 here or something like that. So this is the way I figured out how to do it. So I'm gonna go to parts. And it's going to bring up all the different tubes. Again, there's like 120 of them here. Now, all the way down at the bottom are the new tubes that we're going to be cutting, the 6 tubes down here. Now, one of the things I would recommend if you are doing this while you're in the parts over here in the CAD is I would change the name. So what I did is I clicked on one of the parts and I clicked on it again. It brought up, the screen where I could change it. And then what I did is I went in there and I took out the word straight, because when it prints the label on this part, I don't want it to put straight. I just want the number. I get that it's a straight part. So that's how that works. And then, as you're trying to figure out which part is this is number 125. Well, what you could do is you can come over here and you can turn the part off. You can see over here that it disappeared and turn it back on. Because sometimes you'll be looking for a part in here, like, I don't know which part this is. Where is this thing? And then if you turn it on and off, you go, okay, there it is. That's how I kind of find the parts on there. But in this case, what I can also do is we'll start from driver's side to passenger side, is I'm going to click on this part. And you'll see there's part 128. I don't necessarily care what number it is. I know I'm going to start over here and work my way over here. And then I'm going to go over to transfer. And then for transfer, I'm going to go down to Dragon CAM. Now this is how I go initially from the CAD portion, computer aided design, over to the CAM portion, computer aided manufacturing. Now I'm into the thing that's going to generate the G code and all that. That's the CAM part of this. And what I like to do, just as and again, I'm new to this, but is screen management, is I'm going to minimize this and put it on one side of the screen, and I'm going to put the CAM on the other screen. I'll show you why here in a second. So from here, there's a couple different options. So basically what I want to do is I've got over here on the CAD, I got assembly and I've got parts. And then over here, I want those parts to get in what's called a nest. And before I get there, what I might want to do is I might want to go to the designer. And in the designer, before I go to the nest, what I could do is I can manipulate the part ID and do a whole bunch of other things. And again, I'm new to this. I'll be learning this along the way. But what I really wanted to do for this part was I wanted to make sure that I had the number printed on it. And I could do this like for every single one. I could open up this designer here and I could change, like for example, let's say I wanted that number to be 5 inches from the beginning of the cut, and there it would put it 5 inches over. And then what I could do is nest the part, click on nest the part, and it's going to give me the options for nesting. So it brought up this nesting project 1. And I can save that nesting project 1. I've already been tinkering with it. I'm just going to call it the same thing I called the other one, bumper 1.5, and say, okay, I'm going to replace that one. And then the tube that I'm using to cut this thing out of is only 73.5 inches long. Let me make sure I got that there. 73.5. It's an old tube I had sitting in my shop. And so it'll represent that tube. And then now that part, there's that part right there. And I can put the part right onto that nest like that. But just for this purpose right now, I'm going to go ahead and take that one back off to kind of show you one of the other features that you have for nesting. Let's go ahead and do the next tube. So I'm going to go back over here to CAD, the Bend-Tech software. I'm picking part number 126. I'm going to transfer it to Dragon CAM. And this is kind of a tedious part where I'm guessing there's a faster way to do this, part 126. And now what I'm going to say is I just wanted to go directly to an existing nest, and that was that one. And you can see the number I have is still on there. So the way that I changed it such that all of the parts would have that same marking on there is I went over to tools, I went over to the machine library, and I said, when I clicked on the Dragon, and from the Dragon, I went over to actions, and I said, what I wanted to do on every single part is I wanted to mark it. This is the font, this is the size. I want it to be 4 inches from the beginning of the part on the x-axis, and then I saved it. So that is how I got that number to show up on all of the parts. And then we'll just go ahead and go in there and pick the rest of the parts. So transfer to Dragon CAM. Part comes up, existing nest. I want it to go in there. There's that part. And then here's the last one, which we'll transfer over to this nest. So here's that nest there. Now I've got all 4 parts. And one of the things I can do is I can go and say each one of them, put them into the nest. Or I could go over here and I could do the auto nest. And from what I understand is if you've got like let's say you have a whole bunch, it's gonna take up a bunch of tubes, it'll nest this thing onto the tubes efficiently, and I'll be messing with that later on as we go. But as I click it, you can see it puts all 4 of these on here. Now, one of the things I remember watching when I visited Bend-Tech and I thought was really nifty is like, man, these tubes are so expensive. DOM is crazy expensive. And I don't really want to waste that much tube in there. So one of the things that I can do is I go back over to parts, is I can now click on one of these parts which are on this tube. I can rotate it to line up some of the notches, and then I can move it. I can select that thing and basically close the gap and give myself maybe just a little less waste when these things start cutting, because again, DOM is really expensive. So I'm going to click this last one, find where those things match up, and move that closer together. Okay, and so now this program is ready to go to their Mach 3 to generate the G code and cut this thing out. And this happened quickly. And if I cut these things out manually, it would take forever. 4 tubes, it would take a couple hours to cut all the templates out and do all those kinds of things. And I remind you, I'm a total noob at this. So, if I could figure it out this fast and get these things nested and ready to go, that's pretty impressive. We finally get to use the Dragon A250. So we're going to send this cam over here to Mach 3, get it ready to cut. We hit the Run Project button, and it opens up all these control interfaces, and we connect it to the machine. Now, if you look over here, none of the axes are home, so that it doesn't really know where it is on the machine, all the parts, so we need to do a homing operation. But before we do that, if we don't jog the trolley all the way to the back end of the machine, it will literally take forever for this thing to run a homing operation. So we're just going to manually go at fast speed towards the back. And then now, when I hit home all axes, it'll go through the homing, but that thing will be closer to where it's got a home. It'll take a lot less time. All right, now that everything is homed, we can close this window and hit start. And what it's going to do now is you basically hit start twice to make this thing start cutting. The first time, it's going to take the trolley, it's going to run it all the way forward to that dimension that we put in for the length of our tube, so we can load the tube up. And when we do that, it should be just in the right position to start cutting. All right, let's take a look at how these tubes did getting cut out. I think they look great. The cuts are just super complex and really tight, and they follow the profile exactly. How exactly? Well, I looked at this right here and I was like, oh man, that sure looks like that's kind of an error. I don't know. I don't expect that little nick to be in there, but I went back and looked at the G code, and the way I landed this thing on the tube was slightly off right above, and I had to make that little nick right there to account for the radius of the top of the tube. So the accuracy I think is pretty good. We're going to have to get this thing welded together. And again, my first cut I think is probably as complex as it gets, trying to make it cope to this square tube with this massive radius. To get the tubes to look like the way they do, how did I do that? So first off, I took some soap in a Scotch-Brite pad. I washed these things down to take the soap off, and that way it took the markings, I think, really well, preparing it that way. Once they were out, I used the clutch surface conditioning tool, which I just did a review of. I think it's a great tool. I specifically used this thing right here And it does a really nice job of preparing the ends of these things to get them ready for some TIG welding. Remember, anytime you TIG weld, it needs to be bright, shiny metal. I think it did really good. And here's another cool thing. Here are all of the waste pieces. And you can see that after it's all done, I could probably even get less waste if I, maybe as I was nesting these, nesting them a little closer. But it just does a really great job of saving material. If I was cutting these out individually, I would have a lot more waste at the end of the cut. So I'm really impressed by how this thing preserves some of the metal. But anyway, let's go ahead and get this thing on the truck. I'm gonna have to get a buddy over. We're probably gonna need about 10 extra hands to hold all the pieces together while I tack them on. But let's see how it looks when it's done. Before I get too far into welding this, I just wanted to kind of show you some of the fitment there, how tight everything went together. It's pretty good considering that these tubes have been on here for a little over a year, and then we just kind of fit these other tubes up to it, and especially with this large radius tube on top, I think it's looking pretty good. I'm gonna get it all welded together. Let's take a look at two things before I go ahead and get the lights and the hood back on the truck. We'll do a little bit of painting also. There's a little bit more fabrication left to be done, but some big validation points here. One is that the Dragon A250 worked amazing. The fitment here was just perfect. There was no gaps or anything. It really made this an easy weld, and that's the basic foundation for any good welding, is just cleanliness of the material. I thought the surface conditioner did a really good job with that. And then also the gaps are just really small and made it really easy to make. Well, I thought there were some decent welds. I'm not the best welder in the world, but I've never had a weld fail, so that's pretty good. And the second thing that was validated here was the technique I used for inputting a large radius tube or a rolled tube into the Bend-Tech software. I will be using that again in the future. And if you want to use that, check out the previous video to this one. I'll put a link somewhere, either in the description or hopefully on the screen, for where you can see that video to learn how to put a rolled tube into your own Bend-Tech designs. Well, I am pretty new to the Dragon A250, but I have been doing a lot of CAD videos on Fusion 360 and then also using the Langmuir Systems Crossfire XR. So right now I'm making the mounts that I'm going to put the new road shock lights on and get those things mounted up. If you think you could use one of these in your shop, you can check out a link in the description below, and also code NTD Racing saves you $100 off at checkout. Every time after I make a light bar, I think it's the last one I'm going to make, and then we destroy it by hitting a tree or something like that. But I really think that this could be the one that does it. It's going to do a great job protecting the truck, protecting the lights, and then also protecting our fiberglass. So anyway, I'm going to continue this video with all the long form CAD stuff that we zapped through earlier in the video, if that's what you would like to see, exactly how I did pick points and went through all of the Bend-Tech software to get all the information we needed to cut these tubes on the Dragon A250. Hope you like what you saw. Consider hitting the subscribe. We'll see you next week. Take care of yourself. All right, so as we continue on, I know I mentioned the last video, and some of the important parameters from that last video we got is that the radius of that square tube is 101 inches. The distance that it basically deflects, we use like a 40-inch line across there, and we'll be working on that in a second. The 40-inch line, from that 40-inch line, that radius of that tube deflects 2 inches, and then where the two tangential tubes need to come together is 2.04 inches. So I'll be using those numbers throughout this whole thing. To kind of start with, here's the Bend-Tech software. If anybody asks me what kind of tube notcher they should get, I would say don't waste your money on a tube notcher. Get the Bend-Tech software and a printer. And that is a way that you can design, I think, a tube notcher will give you the ability to cut, join maybe two tubes. But if you really want to have a junction of really complex, 6 or 7 tubes that all meet at one center point, nothing beats Bend-Tech, I think, for that at the price. It's just a great program, and it's pretty easy to use. So let's go ahead and start with how we're going to put this whole thing together. I did a little bit of this on the last video, but I'm going to go through it one more time here. We're going to do some pick points. I need to find a pick point in the center of this. It just happens to snap itself to the center of that tube. And all these values are 0, so when I hit apply, then that's where the pick point is going to establish itself. Now I need to get a point out here, which is going to be the front end of that bumper, right where it tucks underneath the hood. And that's just a point I had to measure off of my truck. And I knew that I wanted that pick point to be forward. It's going to be 10.25 inches. And that's from the center of the tube, not 1,025.25 inches. That'll be from center tube to center of the square tube. And it also goes down 2.5 inches. That's how that will work for my truck. I hit apply, and now that point is there. Now I'm going to reference the other pick points off of this one. So I got to go in there and clear the value so I don't have a random value in there. And like I said, that the deflection of the tube once it was bent, and we had those 3 points for it deflected forward 2 inches, and you kind of go back and watch that video. So I need to go backwards 2 inches to undo that. And then I also need to make sure that I pick the correct reference point. So now at that point, this pick point will be 2 inches aft, and you can kind of see where I put that pick point in there. The next 2 pick points that we're going to make on this will be based off of this pick point. So I'm going to clear the values again. I'm going to select this as my reference, and remember that there's the angle aluminum tube, that our line that we drew there was 40 inches wide, so it's 20 inches to the left. I'm going to hit apply. I'm just going to select right. It's going to put the 20 inches over there, and I'm going to hit apply. And that represents, if you look from above, a 40-inch straight line. So this line, which is like, this will be one edge of the tube, the square tube, this is the other edge of the square tube. And as it's bent, it bends through this point, which is 2 inches forward of the center of the where these are. So that's, and we defined that radius as 101 inches once we worked all that out. Now, again, to make a bend in Bend-Tech, the bend, if it's going to go through this point, it's got to be defined by a straight line and then another straight line, and where you have that center pick point is going to be where the bend will be represented, and it'll basically, once that bend is put in there, it's going to snap itself back to this point. Here's what I mean by that. So I'm going to clear the values. I'm going to select this point right here, which is on the tube. And I knew that forward of that tube, like I said before, 2.04 inches is how far forward that center point needs to be. That's where those 2 tangential lines would meet in front of that tube. I'm going to hit apply. And then now when I go in, now I need to basically make, as I go in to make this bent tube, I got all the points I need for it. I need to have a couple things. I need to make sure I've got the correct tube in here. Now I went in and I made another tube on from the tools library here. If you go down to the tube and pipe library there, and I said the roll tube, and I said that the width of it is narrower than it started, because as it bent, it kind of deformed itself. Now it's not 1.925. So, and I want to be as close and as accurate as I possibly can with these. So I'm going to go and select that rolled tube. And then the 2-inch square tube roller, if I go to the tools and then the die library, and I pick this roller, then that's where I put in the 101 inches that I got off of Fusion 360, and that told me what the radius of that tube was going to be. I put those there, and I save it and close. And then now that I've got these 2 things, I can say, okay, I want to make a bend. I want it to have one bend in it, and I'm going to say okay, and then I'm going to select the points. I start from left to right, and as I make this tube, as soon as I click okay and call it part 8, or I could call it bumper or whatever I want to call it, and I say okay, now you're going to see that tube, just like I had planned for it, is going to go right through the center of that pick point, which represents, this is the center of the under part of the bumper of the car. So that's exactly how I want that to look. And if I go to main, you can see what that bumper looks like now. Now I need to put in some more pick points, because I basically want to have 1.5-inch DOM tubes come out here and grab this bumper. So the center ones will be pretty easy. So if I say put some straight tubes in there, and I go over here and pick my 1.5-inch DOM, and I go from that tube, and where basically there's a whole intersection of tubes right there, so it'll be a really strong point to the center there, and over here to the center of this tube, and I go back to main again. Now you can kind of see how it grabs that. Here's something I don't know how to do. So if you're watching this, and maybe you're even the Bend-Tech guys, you're watching this, you're like, dude, you just don't know what you're doing. How do I put a pick point in the middle of this rolled tube? And here's kind of the challenge there. If I went to lines, and let's say I took this line right here, and I say I want to make a pick point along a line, I set my reference line,
and my point, and I say, let's just say I'm going to make it so it's easy to see, a 3-inch pick point from the end of that line. Well, there you can kind of see from the end of this tube, it put a pick point right there. But I'm unable to do that if I set the reference as being this tube. It just won't let me select it. So you kind of got to trick it just a little bit. And I say that being that I know that I want the pick point to be 16.5 inches this way, but how far back do I want it to be? And I just kind of, flush it out by just kind of guessing to start with. So I'm going to say, using this as my reference and for my pick point, I want to clear all the values first, and I want it to be left 16.5 inches. And then I'm just going to guess back about 1.5 inches. And then I'm going to scroll in and I'm going to see how close that was to that point. And now you can see that point falls right over that tube. So that's pretty darn close to where I want that to be. And it really just has to be inside the volume of the tube and on that line for that 1.5 inch DOM. So to connect to that. So I'm going to say apply that point. So that's there. I'm going to select right. Now it's going to put the pick point on the other side. And then what I'm going to do is I'm going to go in here and grab the straight 1.5 inch DOM again, and I'm going to connect these lines right here to there, to there. And so when in doubt, make a triangle, and you can kind of see, at least in the lateral, that's going to be a pretty robust bumper there. I think if you hit it on any one of these sides, it shouldn't bend itself back into the tire or something like that. So remember, this tube actually extends along a little bit further than this, but putting the tube right here allows me to avoid where I'm going to mount the lights. Now the other two tubes that are coming up from here are going to be 10 inches from the center and go down to this tube, and this is going to make kind of my skid plate, and also a way that we're going to do a better job of protecting our steering setup. So I'm going to go back over to pick points. Again, I'm going to select this point right here, and I'm going to make the left and right 10 inches, but I'm going to go back, I'm going to just say 0.6 inches, just guessing as far as how far back I need to go. And if I go to that point, I just got lucky. 0.6 inches is it. Like, let's say I went over here and this was 1 inch, and I kind of come back. You can kind of see up that point does not fall on that tube like I would want it to. So if I go back and change this to 0.6 inches, now it does. And that's the only way I know to do this. And I'm sure there's a better way to do it. I just don't know what it is. So if you know, please put it in the comments, contact me directly, and I will try to fix it on my next video. So I'm going to hit apply to that, and then hit left and hit apply. And then now I've got those 2 points. Now, in general, whenever you are making a roll cage or something like that, you like to have nodes where, like, say, all the points come back, all their center lines come to one point. That's the strongest point on that roll cage. And on the front, I would like to do that, but the geometries just don't only do that, by clearing the lights, and then also without looking too goofy, I think, on there. And so now what I'm going to do is I'm going to go ahead and grab these pick points again. I'm going to say, get the straight 2-inch DOM tubes this time. We go from the center, from that pick point to the center of that tube, and then from this pick point to the center of that tube. And then when I go to main again, and now you can kind of see what that's going to look like on the front. We'll be putting a skid plate up there. I think that'll look pretty trick. So now what we're going to do is we're going to go in here and make the cut profile. So how are we going to cut these things out? And it shouldn't be too difficult because there's only a couple of them that overlap, but you really got to kind of just remember how they overlap. So you got to give yourself some rules. So in this case, let's start by cutting these top ones. I'm going to start by cutting the inside ones, and I'm just going to let those, I'm going to say cutting, and I'm going to go through and erase, delete all of my cuts. Yep. So I'm going to get rid of all of them so that all the cuts I have down here are the ones I'll take over to the Dragon A250. I'm going to say new cut, and I'm going to pick this one, and I'm going to cut it in relation to this tube. And so we'll say every cut that is on the passenger side will be the primary cut, if you will. So I'm going to cut it in relation to that tube on that side, and I'm going to complete that cut. And then I'm going to say another new cut. It's going to be this side of that tube. I'm going to cut it in relation to that tube. And since this tube's already there, I'll pick that one, I'll pick that one, and pick that one. It's not actually going to touch those, but you never know. I usually pick all the tubes that will be there before this tube at that junction. And I'm going to say complete that cut. So now 125, you can kind of see what the profile of that cut is going to look like for that one. And when I say like which tube is there first, now as I go back and I say make a new cut, let's say I want to cut this tube now. Well, on this side, it's just going to be, it's only going to be cut in relation to the bumper. and I'll complete that one. But as I go to this side of the tube, new cut, I cut that side of the tube. Now it's going to be cut in relation to that tube, that tube, that tube, like we talked about before, those ones before. But now remember, now this tube will already be there. So it's got to be cut in relation to that one. And when I hit complete and you kind of roll in here, you'll see how there's that little profile where it's going to go over top of that, this tube that goes across here. So if you didn't kind of have a good rule for how you keep those in order, then you might get to a point where you have either cut too much out of a tube or you haven't cut parts out of a tube that you intend to cut out. So, and again, since I said that the ones on the passenger side are always going to be primary to the ones on the driver's side, when I go and say new cut and I say this tube right here, I know I need to cut it in relation to that one and this tube right here. And so you just got to kind of keep track of which tubes are already going to be there. That tube will be there before that tube. And I say complete, and then now you can kind of see that it has that radius there where it's going to cut itself and have a notch out for that tube. And so from there, I'll go through the rest of them using that same rule all the way across. All right, so now we got them all selected, and you can see we have 6 individual tubes. We've got 12 different cuts that are going to have to be made. Let's go ahead and figure out, and this will be the new part for me, is how we put this into Dragon CAM and get ready to cut this out on the Dragon A250.
Hey there everyone, my name is Dave and welcome to the NTD Racing Speed Shop. Behind me is Lefty, our budget desert race truck. And right now I'm working on building a light bar. So I'm doing something I've never done before. I'm using my tube roller called the Hulk from Swag Off-Road and bending 2" by 2" square tube with a 120 wall, so 1/8" wall. It's pretty hefty stuff. And here is what the bumper kind of looks like. You can see this radius that I'm working with on the bumper. And so this video is going to end up being super long. So I'm going to break out the piece where I show you how I take the measurements from this piece of metal. I put that into Fusion 360 to figure out what the radius is and some other dimensions. And then I put those into the Bend-Tech software such that I can make the other tubes around this thing and we can put the Dragon A250 to work. So let's go ahead, head over to the bench, pull some dimensions off this, and then we'll put them into the computer. Let me show you some of the things that we will be using to get the dimensions off this tube. Let me just show you real quick. These are the Harbor Freight Road Shock Edge lights. And I made a whole video on how I made the first light bar, and then we made another video after the Mint 400 where we ripped the light bar off. So all 6 of these lights are sitting out there in the desert somewhere, but Harbor Freight sent us some more, and they are hands down the best off-road lights I've used, and I've used them all. I've used the most expensive, and I used the cheapest ones before. These things are awesome. Anyway, some of the other tools here, we got angle aluminum. I use this stuff for everything. It's the greatest straight edge, and you can write on there, and I have all the markings on there kind of already primed up. This is something off my 3D printer. Helps me find the center of a tube, a square tube especially, and I'll show you how I'm going to use that. And then the tape measure. So let's go ahead and pull some dimensions off of this tube. All right, so first off, this tube is longer than my piece of angle aluminum, and that's totally okay because you can still figure out what the radius is, which we're gonna have to use later. But the first thing I wanna do is I wanna mark the center line of this square tube all the way around. And again, I'm gonna use this thing that I printed on my 3D printer. I've got a whole bunch of videos of me using the Creality Ender 3 3D printer, which I think is just like one of the coolest tools that you can have. The more you use it, just so many cool things you can do with it. We make RC car stuff all the time. So you can check out a couple of my videos on how I use that. But this tool does a really good job of marking that center line on that tube. Now what I have is this piece of angle aluminum, and I've already marked it. It's about 44 inches long, but I've marked it at the 20-inch point and the 40-inch point. So basically, I'm going to measure 40 inches across this tube, and I need to find the center point, because what I need to do to define a circle or an arc is I need 3 points, and I'm going to show you later on when we use Fusion 360 why I use those. But what I'm going to do is I'm going to take the tip of this angle aluminum and I'm going to put it on the line, and on the other, somewhere else on the line, on the same line that I drew with that pencil, I'm going to put the mark that I have for the 40 inches exactly on that line. So I got both sides on there. And then now you can kind of see I can define, left and right, 20 inches left, 20 inches right. Now I need to be able to define just off the center, how far is it onto that center line, that same center line. So from the 20-inch point that I marked on this piece of angle aluminum, as I measure it up, it's just, I don't know why the math works so good. This is awesome. It's exactly 2 inches. Okay, so we got those points now. Let's go ahead over to Fusion 360 and we'll put those things in there. I'm gonna show you how we find the radius for this tube that we rolled in Swag Off-Road's Hulk tube roller.
All right, we're going over here to Fusion 360. You can still find this from the generous folks at Autodesk for free for home use, non-commercial use over here. And so what we're gonna do is we're gonna sketch on Fusion 360 by clicking on this button up there. And the plane that I always sketch on is this Y and X plane. So you gotta pick one of these. So I highlight it and I pick that Y and X plane. And then whenever I use the word hotkey, that means I'm hitting the key on my keyboard. In this case, I hit an L and you can see where it selected the line. Now I can just go over there and click on line also, just a little quicker using hotkeys. I'm going to go ahead down to this red line down here. This is the y-axis, and I'm going to go ahead. Once you see that it makes a box over that, it's going to let you snap your cursor to that line. I'm going to hit the left mouse key and start drawing this line out. I want to make sure that, as you can kind of see, as I roll it up and down, the degrees change. I want it to stay snapped to that line where that degrees equals 0, and I'm going to put the length of that piece of angle aluminum on there that I had, which is 40 inches, and then I'm going to hit enter. Now that line is on the basically the plane there. So now we'll go over here to constraints, and these kind of lock in parameters for whatever it is you've got. In this case, I want the midpoint, because what I want is I'm going to select this line. I want that midpoint of that line to be at the center of the X and the Y axis there, and you can kind of see how I centered it. Now I have 20 inches to the left and 20 inches to the right of that center line. The third point that we pulled off of that tube was 2 inches. So I'm going to hit hotkey L, and from the center there, I'm going to go straight up 2 inches and hit enter. And now I got the 3 points which are going to define this circle. Now to make circle, I can hit hotkey C, and you can kind of see where it brought up the circle over there. But what I really want is to click on this create option, drop down to circle, and you can see the different kinds of circles I can make. But the one that I want is a 3-point circle. And to make that work with this, you need to start with the center one where you see it snaps, it makes that square box there. I'm going to click on that, and then over to the left side and over to the right side. And now you can see, now it has made a circle defined off of those 3 points. I'm going to scroll out until I can find the origin of that. I'm going to hit hotkey L, click on the center of that, and now we can see that the radius that it made is 101 inches. So I'll write that number down because I'm going to need to put that into the die library in Bend-Tech. All right, so one other thing we need to get out of here, the last dimension, is with Bend-Tech, when you make a bend, is which we're basically doing here, you have 2 straight lines, and where those 2 lines meet, which are tangential to your circle, in this case, that is where you're going to put a pick point, and that's how we're going to define the circle. Basically, that center pick point is where the bend is going to happen, and it's usually outside of wherever the bend is going to be. So to do that, I'm going to hit hotkey L. I'm going to go over to the intersection of the radius of the circle and where that straight 40-inch line was, and where it makes a box there. I'm going to click on that, and then I'm going to run it over to the x-axis, this green line. I'm going to kind of run it down until I see that it has made it tangential. There we go. You can kind of see as I kind of run up and down that line, and if you look over to the left side where the intersection again of the arc of the circle and that 40-inch line, you can see there's a symbol there that's a circle with a straight line, and that's the constraint, which is tangential. So I'm going to click on that to lock that in, and you can kind of see that tangential representation up here in the constraints. And basically what that means is that's the closest point where that line will touch the circle, but it's not going to go inside the circle. I'm going to go over and do the same thing on the other side. You can see that tangential constraint symbol over there. I'm going to click on that. And then now that's where these two, basically tubes will be represented in Bend-Tech software. And where they meet, I kind of need to get that value right there. So I'm going to hit hotkey L again. I'm going to click on that point and find out what the distance is from there down to the arc of the tube that I made, and I see that it is 2.04 inches, so I'm going to write that number down. And now I have all the values I need to go over to the Bend-Tech software and make this tube. So we're making it over here in my old roll cage, which I call is Lefty, the one I took to Bend-Tech to cut all the tubes for it. Now, this is the Bend-Tech CAD software, which is amazing, and I'm asked all the time, or at least I see online people say, well, what kind of tube notcher should I get? And I say, don't get any tube notcher. It costs you more than buying the Bend-Tech software. With the tube notcher, you're not really going to be able to create very complex nodes like this, which you can with the Bend-Tech software if you just got a printer, like a paper printer, to cut out the templates to make those cuts, and then an angle grinder I think is amazing. I did happen to cut this one out at Bend-Tech using the Dragon A250, which I have in my shop, and it's an amazing machine. And I'll show you how I use that on the next episode if you tune in for that. But anyway, we're going to make a pick point because, again, that bumper is going to be off here on the front, which is going to hold our light bar. So I'm going to go to pick points. I really need to kind of anchor that off of the center of this tube right here. So I'm going to select that, and I'm going to put no values in here and hit apply. And that just put a pick point right there at the center of that tube. Now this bumper that I'm putting out there, just the geometries that are going to work on my car, are that's going to go down 1.25 inches. And then the front of the bumper, to tuck it underneath the hood, is going to be 10.5 inches. And that's how far it's going to go down and forward. I'm going to apply that pick point right there. And now I'm going to use that pick point as a reference for the other pick points. The first 2 points that we need to find are defined by that 40-inch piece of angle aluminum. So I'm going to go ahead and clear all the values. We know that was back from that point 2 inches. And then we also know that it was 20 inches left and 20 inches right. So if I go back 2 and 20 left and hit apply, now puts a pick point there. Now it was 20 inches the other way too, so I'm just going to click on right. You see it flip that value of 20 over to the other side. I'm going to hit apply, and then now I've got those 2 points. And then the third point, which defines this tube that's being arced, remember, was 2.04 inches forward. So I'm going to clear the values of that. I'm going to say 2.04 inches forward of that pick point that is on the tube, and hit apply. And now I've got the 3 points that I need to define what this tube is going to be. So from here, there's a couple things that we need to do with the other values that we had to make this work out. First, we need the value of our tube that we have off of our tube library. I already have 2-inch square tubing in there, but the 2-inch square tube, the rolled one that I have, what you need to do is tell it, well, what was the radius? So you go into Tools and you go in the Die library, and if I click on my 2-inch square tube, you can see I already have that in there, the 101 inches. So you just put that value in there that we pulled off of the Fusion 360. You'd say save and then close that. And then now you need to make sure you have the right size tube, the right size die. You would click on bend, and then now I want it to have one bend. I'm going to say okay. And then I would just kind of connect the dots from left to right or right to left, doesn't matter. And you can see it's going to call it part 8. I could call it my bumper. I'm going to click OK. And then now it's created that tube right through that one point we knew it was going to do. And if I hit main, you can kind of see what that rolled tube is going to look like right on the front of the truck. And then in the next episode, if you tune in for that, I'm going to show you how I connect all these things up and complete this light bar and basically bumper on the front of the car to hopefully we won't rip off at the next race.
Well, I hope you like what you saw here and you'll consider subscribing and even more importantly, hitting that notification bell, which will tell you when the next video comes out where we finish this whole project, get the light bar on there with those awesome road shocks from Harbor Freight, and most importantly, get the Dragon A250 to work. So hope to see you next week. Take care of yourself.